All right, good morning once again. We have been having a discussion for a couple of minutes before I started doing the recording, but there is another important part of bar charts, which has to do with questions they ask, which relate to your table, the data you use to draw the graph, and it's important we talk about. So I'm going to center today's lecture to that. And I'll be taking you back to the assignments I've already reviewed, okay? So I'll pick one student work and we debate about that. Because I give an assignment, and in the assignment there is a sub question we need to solve. Grace, do you have the question?
Yes.
Um, use your phone to take a picture of the question and put it in our chat because I'm going there. Do it now, quickly. Or it's even on a page. So just forward it. So we're going to review one student's work.
Why we
Hurry, hurry. Okay, she did that. Okay, so, oops. Okay, so there's a question. Yeah, so the table below gives the frequency distribution of the marks obtained in a class test by a group of 64 people. Then you have the marks, you have the frequency, and you were asked to draw a bar chart for the distribution. So we'll look at the bar chart quickly. Yeah, but just take a few moments to observe the data. Okay, so we look at the graph. So all the time, marks will come to the x-axis, the horizontal line. Then frequency will come on the y-axis, which is the vertical line. It's important to label the axis. So x-axis, y-axis, then name the horizontal line. So it represent marks out of 10. Let's say represent frequency. Then now, the frequency, you have to give it a scale. So you observe what is given in the question. You'll notice that the frequency, the highest number there is 14. The least number is 14. So if you are dedicating every 2 centimeter box to 1 unit, yeah. If you are dedicating every 2 centimeter to 1 unit, that means that you have, instead of what she's done, we are looking at the y-axis, okay? What she has done, which is 2, 4, 6, 8. You should rather be doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last number you get is 12. Guys, do you hear me, or there is some breaks? Yeah, yeah. The last number she will get will be 12. But in the frequency table, it's 14. The highest number is 14. So she was wise to make it 2 units for every 2 centimeter box. So every big box, she will be moving as 2 step. So 2, 4, 6, 8. In that case, the highest number she's recording is 26. Fine. And you'll be able to get 4. For 14, yeah. Now, note that the x-axis, we do not write a scale. Yeah. Just mount the box. Then you just go to the question. Whatever number is there under marks, just position the number in the middle of the box. Just target, no measurement. Yeah, so once you have this, you just pick, you know that the first box will represent 2. The frequency is 9. So you draw a box to correlate to the ninth mark. So she raised the box to 9. The next one, you raise the box. We are dealing with the frequency. You raise the box to 14. 14, which is then the highest of all, and it's clear. You raise a box for 13. 13 comes before 14, and so on and so forth. And that's it. This is what bar chart is about. When you are done, then you just write the values for marks under the boxes. Okay. So we did it in our previous lecture. I'm glad some of the students have been able to demonstrate that graphically, and yeah. I'm using that for a lecture. So let's concentrate on the part of today's lesson, which is the B. It's the action of probability. Probability is something I'm going to teach you because in exam, compulsory question number 5 is a probability question. Yeah. So I've given you what you are to expect in exam, right? The compulsory question number 5 is a probability question. So I've told you, so don't be surprised when you see it. Okay? Yeah, every time. So, and this, I will teach you probability, but since this is asking a probability question, let's use that for our lesson. So they said a pupil is chosen at random from the class. What is the probability that the pupil obtain 7 marks? Okay, let's learn. Are you ready? Are you ready?
Yeah.
Hmm. Probability comes from the word
Probable.
good.
Probable.
Yeah, probability comes from the word probable. Yeah, let me see if just a moment. Okay, yeah, probable. And when we say probable, we mean likely, right? Likely, right? So under probability, we just look at the possible chances that can occur in a given situation, the possible chances that will occur in a given situation. All right, so we use certain games and scenarios in life to illustrate this. So we all know what a Ludo is, right? Yeah. Yeah, it's one game. Yeah, we normally use a die. A die looks like it looks cubic, and we have 1, 2, 3, 4, 5, 6 on it, right? And you'll be playing that. You throw the die, right? You throw the die, and you're not sure if you're gonna get 1 or 6. I believe you know the game I'm talking about. Hannah, do you know the game I'm talking about? Did you ever play that?
Yes, sir.
Yeah. So, So you see, that game, there's too much possibilities. If you play, you either get, what are the possibilities? You either get a 1 or what? 9 or 9. So, what are the possibilities? The chances is 1 to what? 6. Another word that just came to mind, chances. Yeah, 6. So it happens. Okay. So number two is when you are tossing a coin. when you are tossing a queen. Come in. Just hold on. So when you are tossing a queen, you either get, it depends on the queen you are tossing. Okay. It depends on the queen. So there's a Ghanaian currency. Yeah, so it's either you are getting a coat of arm, right? Or there is a woman in front. You get that? Mm. You're either getting a coat of arm, like when you throw in it like that, you either get. So we use the word, we normally use head, yeah, or tail. So in your head, you can represent any side for head or tail. Let me look at the Canadian queen. It's also a woman, and they have. I don't know. This looks like a polar bear. You know that animal called bear, right? A bear. A bear. It looks like a polar bear. I'm not sure you will see. So there is a bear, then there is a woman. I presume it's Queen Elizabeth. Yeah, so you can dedicate one for head or one for tail. So if you throw that, you're either getting a head or what? A tail, right? So that's where Queen and so much more, right? So probability is a game, is the idea of probability is something we extrapolate to or get had from the game of chances, throwing a die, tossing a coin, and I mean a lot. Even cards, the guys, you know that cards. The ladies are even familiar with that. We call that a speed. A speed, the cards. The ladies, let me help you out. Those cards that you have queen, I don't know. They have a lot of characters on it. Back in the school during creative art class, where you were made to use that to build a house. That cards. Oh, the guys they play it like this. I don't know how to play that though, but they'll be starting it like that. And then yeah. You don't know what I'm talking about. Yeah. You call that a spa. I don't think that's the right word. The right word is speed.
Yeah.
Speed. SPAD. Look it up and let's see.
Okay.
It should be speed. SPADE.
So you're looking at our hand.
Yeah, look it up.
How do you How do we call a deck? Spade. Yeah.
Yeah. I think it should be speed, not spa or whatever, right?
What's this?
SPADE. Did you check it out?
You know what?
You can write speed game. Like speed game, and I think you get that. What is a speed?
Huh? Yeah.
Look at speed, the now aspect of it. Yeah.
What's it? That's a small board game.
See, this part of the map line, we have
There's no spade.
It's what?
the spade is one of the characters.
One of the characters.
Yes, yes. Like
Okay.
the diamond, the spade,
Okay. So then the best we can say is maybe cards, right? Cards. Because even in mathematical concepts, when we are giving questions, we write the questions are posed this way. someone was drawing a card from a pack of cards. That's the expression we use. Okay, that's the expression we use. Ajwa was made to draw a card from a pack of cards. Okay, and then I'll ask you, what is the probability that she gets an even number of stuff like that? Are you listening? So I think then it's better to call it cards. If spade is just one of the cards name or whatever you are seeing.
Yeah, it's either a deck of it's either a deck or a pack of cards.
Okay, a deck or a pack of cards. Nice, 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 nice. Thank you. Okay, so yeah, that is it. But what you'll be meeting in exam is mostly like someone drawing a card from a pack of cards. Yeah, that's the expression you mean. Okay, now when you are drawing a card from a pack of cards, what is the chances? I know that for those cards, they are numbered though. It's from 1 to 52. It's 52 cards. Who knows? So the guys you should know this because I don't play that game, but I'm familiar with it.
But you take some out.
No, but when you buy a new one, it's 52 pieces.
Yes, sir.
Look, you can just go to, I don't know if it's a bookshop you get or any big provision shop. You will get one there. You can buy one. It's 52
Right.
pieces.
Game.
This is going by some.
So Evelyn, you don't know this game because even when we're infants, we used to play that. We do red or black, right? So we just pick that and you ask your sister or whoever you playing that game with that red or black. So the person says red. Oh, maybe what I'll pick is black then. Oh, you didn't play that game? Come on, you guys are boring. You didn't play that. What were you doing during infancy? Come again. I didn't get them. What are they saying? Tumana koko. Okay. Oh yeah, but that's the same thing. Where we were back in school, we're doing that red or black, you know? Yeah. Yeah, so when you buy uh, a card, like a pack of card, like one piece, it's 52 pieces in a box. When you go and buy that and see. So in exam, if you are seeing someone is drawing a card from a pack of cards, just know that her chances is 52. So we don't deal with spade or him, queen or king or I don't know what characters you have on. We don't deal with that. We deal with the number of cards. You know, the cards are numbered. You see one, you see two, you see three, 52. So we use that for the question. So so if you are drawing a card from a pack of cards, it's either you are getting one or the person is getting two or three or four or five to 10 to then 15 to 52. Do you understand? Do you get me? It's not anything out of the world. So I'm like, say who ye card every pack of card. What are the chances? That's the question. See, baby, son. What are the chances? And I'm a person who said, when you are buying a card from the market or wherever, auto box now in the box is 52 cards. 52 cards, mark 52. Your number card any biya. And they've drawn characters and they have colors and all of that, but it's 52. Nti sɛ meka kyerɛ wo sɛ adwoa card no yi baako a what guys what are her chances sɛ card na adwoa yi no what are some of the things we are to expect what are some of the things we are to oh so card na adwoa you know chances the chances yeah card no obi no na one like one ya tro so and answer card obi na two and obi na three and obi na 4 5 6 7 8 9 10 like all the way to 52 that's their chances so do you think Ajwa will remove a card and like guys this thing is very interesting and you know I'm going to tell you one thing but I just want to know if these people are following just a minute Rahel, I believe you are following what I'm talking. It's very interesting. I'm going to show you something, how practical it is. Um, Rahel, would there be, do you think Ajua will remove a card? Not card and the also 95?
No.
No. Do you think card no be, obey card na also 45? Do you think so? 45.
Yes.
Yes. So you know the chances, right? And let me tell you how interesting this is. So probability is very in fact, Martin itself is very interesting. Most of its concepts are very practical. Some of them you're able to see it now. Some of them, when you go to university, you build on, you see how useful it is. So let me tell you one thing. You see the bags, the Ecolag. At first, the bags we've been using, the Ecolags that came first, we use padlocks, right? Now the Ecolags that we are having, we use code. You know that, right?
Yeah.
We use code to lock it.
Yes.
Do you know that with this concept of probability, you can, even if you lock your bag, okay? You put in a code and you've forgotten the code. Do you know that this concept of probability at SHS level, you guys can just sit down and produce all the possible codes, okay? Then you start to doing them one, but you do this, it doesn't work, then you think you do this, it doesn't work, you think. In fact, the chart we have produced after teaching you the concept of probability, you know that the code for the bag is here. It's on this chart. It will not come from anywhere again. Like the code is within. So you just take one. It doesn't work. You take that. You take the next. By the time you get to the last code on your sheet, the bag will open. That's how interesting it is. In fact, I use that a lot. I remember I bought one Ecolag and I took it on a trip outside the country. And when I came back, I didn't reset it. I forgot the code. Yeah, but I didn't worry because I knew I would open it, right? So I just got one day off. I was free. I produced the code. I sat down and I opened my bag and I'm using it now. And I'm going to teach you that. Not only that, you see at first, the credit cards were used, and before I continue, you see the codes we've been using for the bags mostly is 4 or 3. It's 4 codes or 3. Now the credit card we're using back then, it was 14 numbers. It was 14 numbers. I don't know if you ever use that. Now you just use mobile money. At first, we were using credit cards. Yes, the concept is probability. It's probability, it's 14 numbers. So you can generate to those numbers and you can be using those you can be using the numbers to be getting credit for free. And the telecommunication network are smart. So they know that if the code is 3 or 4, that one you can just sit home and take your time and use your hand. But 14, it will take you like a month, and you need a very big sheet, like A3 sheet or something, a very big sheet to produce those codes. So they deliberately use like more, they get 14 so that it's exhaustive, right? But even if you transcend to university, you learn about coding, where you give something to a machine. Like you program something to the machine that, look, I'm coming to give you this. Just pair this to this, pair this to this, pair this to this, and give me the result. Okay, so you give the instruction to a system in terms of code, and rather than using your hand to produce all the 14 codes, the system will do that. You see how interesting education is. You just give the instruction to the system, and it will you'll be there and it will be generating the code for you. That's programming or coding or whatsoever, right? So that's how interesting probability is. So it's like possible occurrences you expect, okay? And that's the whole concept of probability, right? So now, one thing I want to show you. So now, if we call something event, can you guys hear me?
Yeah.
We call something event, okay? It's a technical word in probability, okay? And it has to do with a situation. okay, or the case under study. Okay, so if we have a pack of cards and Ajua is made to draw one card, and I'm asking you that what is the probability that the card should draw from the pack of cards? Okay, the number should get is an even number. What is the probability that the card she's drawing from the pack of cards is an even number? What is the probability? Event of getting an the an even number. Okay, so the case of having an even number when you do the withdrawal, okay, it's what we call event. And of course, like yeah, she's to draw a card from a pack of cards. She is likely to get numbers from 1 to 52. She's likely to get any of these. Now I'm like, what is the chance of getting an even number? Okay, for her to get an even number, it's either she's get even numbers, right? Two numbers that are divisible by 2. To get an even number, it's either she's getting 2 or 4, right? Or 6 or 8, all the way to 52. Tell me one. 6, 8. Yes, continue for me.
10,
10.
12,
12.
14.
Yep. Yeah. Like if she's so lucky and she's getting an even number, these are the even numbers she's to get. So yeah, the case under study is what we call event. So someone is throwing a die. What is the probability that the like what she's going to get after displacing the die? What she's going to get is a number less than 3. If you are throwing a die, it's either you are getting 1, 2, 3, or 6, right? So the probability of getting a number less than 3 is what? Should be what? Meaning, what numbers are you looking at? 1 and 2, right? So to throw a die, the likelihood of getting a number, right, less than 3 is what we call event. So if you meet the word event, it's the situation under study. Do you understand? So getting a number less than 3 is the event. Okay, so now watch closely. Now I'm come to give you a formula. In probability, okay, in probability, okay. If I ask you to find the probability of an event, so the probability of getting an even number or the probability of getting a number less than 3, right? If I ask you to find a probability, like someone is throwing, look, the word probability means the likelihood, the chance. Like, don't think too far, okay? Oh, our joy is to draw a card from a pack of cards. What is the likelihood of getting an even number, right? So that's probability of an event, the likelihood of an event, right? So if I ask you to find the probability of an event, okay, it's yes.
Say your brother.
It's okay.
Many more than yeah, is equal to the number of that event, okay, over the like number of sample space. So I'm going to explain, okay? I'm going to explain. So, what is the probability of what are we talking about? She's drawing a card from no, let's use a die. The card from a pack of cards. The chances is too much. Right. So she's throwing a die. What's the probability of getting a number less than 3? Oh, and you guys said is either she's getting 1 or 2, right? So the number of events is what? is this. I mean, you said one or two, right? So the number of events is you count it. One, two. Is what? Two. All over. The number of sample spaces. What is being discussed? Oh, throwing a die. You know that if someone is to throw a die, the sample space or the possible chances is what? You are either getting one, two, three, four, five, six. You are to get to these six numbers, right? So the total number of sample space is what? Six. If you are to draw a card from a pack of cards, the total number of chances is you are getting 1 up to 52. So the total number of sample spaces is what? 52. So if you don't know certain games and the chances, okay, the possibilities, that's where the issue is. Do you understand? So there's a formula, and if it can be simplified, you simplify. I want to change the formulas slightly. Use over total, okay, total number of sample space. That's all. Please, do you have any question? So we are now coming to the question. I know you guys did that, but we may not have the chance to do probability, right? So I'm trying to give you a lot of insights so you can use it for your elective math or your core math. Okay, so now back to the question. So you see, here they are not giving us any game whatsoever, but I mean, you know the number of people, like the frequency. They said this is a table for marks obtained by like 64 students in the class. So when you go to a class, 64 students were there. The marks they had in the test is as follows. So two persons. Oh, sorry. So if you are looking at um nine people had two. It was even marked out of my dear Eve. No, Eve, my friend Ododo. My main friend. So Andrews, you are in a class, eh? Andrews. If you look at the table, the exam was scored out of what? You know, exam, sometimes we mark out of 100%, sometimes we mark out of 20, 30. This very exam, they were marking out of what?
9.
Oh, my brother. Um,
10.
Oh, 10. See, guys, I am pay attention. Nipa no chere no on chere. Teach him how he had the 10. I want him to know. Yeah, sure. You see marks out of 10, right? So meaning it was scored out of 10. Okay, it's fine. Maybe he didn't read. I was trying to read the whole thing for you. So it was marked out of 10. So some people had two marks. It's 9 people. 3 people had sorry, um, 14 people had 3 marks, 13 had 4 marks, and so on. Now they said, now we are going to select a pupil at random. So a pupil is chosen at random from the class. From the class. So we are taking people from the class randomly. What is the probability that the people obtain 7 marks? So you have to look at the number of people that had 7 marks. Then you divide it by the total number of people in the class. So easy. Okay. If I'm moving too fast, just let me know. Okay. So you know that. So this one, you have to code to the formula. Okay. To start, you see, it looks like the rest of the question is probability, 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 probability. So just code to the formula. Yeah. Of event. So probability of an event, okay, is equal to number of events. You have to quote the formula, guys. Over total number of sample what? Space, right? So I know the rest of the question is all about that. So I'll just write this on top. Then now the rest of the questions. Are you ready? So it was like probability of getting 7 marks or something. That was the question. Obtaining
Yeah.
7 marks. Yeah. So you put it in bracket, oh, then because so you just look at number of people that had 7 marks, which is what? 8%.
Eight.
Yep. So 8 over total number of samples space. That's the total number of people who understudy in the class. There are 64. Even if you don't know, just add all the frequencies, okay? So that's 64. Then you use your calculator to simplify. Help me out, guys. Good. Guys, you have to simplify, okay? Now, I have few minutes left. I'm going to fuse a lot of things in here, so pay attention. I'm going to give you some questions you are likely to expect also. So the next one, probability of what? Getting 3 marks, right? They said, what's the probability that the pupil obtain 3 marks? Is someone sleeping in the class?
No.
Good. Oops. It's madam in the class. Obtain 3 marks. What's that?
14.
Yeah, 14. Then you divide by total number of sample space, which is what 64. What's your answer? You're just not reliable. Let me use my calculator then. 64. 7 over 30. Yeah,
Yes.
you people, they only help you once, the rest they leave you in the stream. Okay, next one. So don't think I just enjoy writing stuff in brackets. It's a must. Next one. That one will not. Oh, we have to solve. These are some of the questions I wanted to talk about. But let me finish writing first before we debate about it. Probability. Guys, so the evening students, I'm not really done with the meeting with them. That's why I've not sent you the excerpts from the meeting, like what happened and the fees you were telling me. Okay, so when I'm done with them, then I'll draft a summary of the meeting and send it to you on all angles. So then if you want to show it to your parent, you do that. Okay. Okay. Done. 6 marks. Yeah, so let's come back. They said the person obtained more than 6 marks. More than 6. What are the marks people have? They have 2 marks, 3 marks, 4 marks, 5 marks, 6 marks, 7 marks, 8 marks, and 9 marks. So you're asking to find the probability that the person obtained more than 6 marks. Then what marks are we looking at? Don't be biased. Patience. What marks are we looking at?
Say 7, 8, and 9.
Good job. So we're gonna have yes, oh yeah, more than 6 marks. Let me come back again. So we're looking at 7, 8, and 9. But mind you, we are looking at 7 marks, 8 marks, and 9 marks, right? So let's correspond it to people. How many people had 7 marks, 8 marks? So we have 8 plus 2 plus 3. Okay? 8 plus 2 plus 3. Yeah, then you divide by the total, which is what? 64. Right? What's that? 13.
10.
Can it be reduced further?
No.
Okay. Another question you are likely to meet is less than. So let's see if it's there. Yep. Obtain less than 4 marks. Let's write. The light is on you. Frank, so get ready. Obtain less than, no, Prince. Less than 4 marks. So just 4 marks. So Prince, less than 4 marks means that what marks are we looking at?
2 and 3.
2 and 3. So all the time corresponding to the frequencies. You don't use the marks, so don't be confused. So me, when the question comes, I try to read and understand the question. You have to understand the question. Oh, this question after reading, we know is about marks, right? The marks, we have to understand that, oh, it's out of 10 and some people have 2 marks, 3 marks and stuff like that. Frequency has to do with the number of occurrence, number of people that had those marks. I have to understand it. If you don't understand the question, you will not appreciate the sub-questions given to you. It's not fun, you know? Yeah. So he said 2 and 3 marks. So correspond to the frequencies. We have what? 9 plus what? 14. Which is all over 64. Which is
23.
can it be reduced?
20.
Okay, 23.
23.
Okay, I got it.
Director.
I got it. Yeah, I'm changing that.
No, 9 plus 23.
Yep. What's that? Can it be reduced?
No.
No, sir.
Now, another question you have to watch out for. Find a probability. Like a student is choosing a random. Find a probability that the person obtain at most 7 marks. Okay, think about it because I'm now come to think about it too. Obtain at most 7 marks. Did I say 7 marks? At most 7 marks. Okay. At most. So they had a variety of marks. Probability that they had at most 7 marks. So what are we looking at? I'm done thinking about it. Yeah. You can reason it. At most 7 marks. You can get all the marks, but your most.
Yeah.
You go. Yep. So talk to me. So what marks fall in this category?
I think it will be 2, 3, 4, 5, 6.
7.
7. It's inclusive. But if I tell you at most 7 marks, look, guys. So we are doing offering time, okay? And I tell you that all
Yeah,
monies, I'm expecting at most, like your individual contribution, I'm expecting at most 10 cedis. It means that it doesn't mean if you have 10 cedis, sit down, right? Yeah, so we're looking at all monies, like 10 persons, 20 persons, blah, 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 all right? And including 10 cedis. Most means, hey, don't go beyond. Most means don't go beyond. So whatever we're talking about in most, that number is inclusive. So including 7. So at most 7 marks is we are looking at 2 marks, 3 marks, 4 marks, 5 marks, 6 marks, and 7 marks. So that's 9 plus 14 plus 13 plus 10 plus 5 plus 8. Please, if you have any question, talk to me, please. I'm going back. 10 plus 5, then plus 8. Oops, I didn't include a 10. Oh. Let me add a 10 here. It's fine. You are learning, so let's 9 plus 14. It's fine. The 10 should have come, let's see, before the 5. It should have been here, but I just don't know. So it's fine. Add it up. $59/64. If you have any question, ask me, because I'm coming to drop another one. Okay, let me ask you this question. Find the probability that the student obtain at most 4 marks. Sandra, think about it and help me out. I'll go around. At most 4 marks. So meaning, what marks are we looking at?
Four, 5.
I said at most 4 marks, right? So what marks are we looking at? Oh, no one should teach her. Okay, I just want her to just feel free to talk to me.
4.
Just mark 4. Sandra is lost too.
And
Rahel.
5.
Sandra is so lost. If I say, you see, this is probability, my dear. If I tell you the student obtain at most 4 marks and you are just telling me 4, no. Probability meaning there is other possibilities, but it looks like you are just telling me 1. No. Probability, there you have to list a number of possibilities. In fact, I have to list everything involved. Everything involved. Rahel, will you try? Talk to me.
2,
Come again.
2, 3, 4.
2, 3, 4. Please, we are looking at 2 marks, 3 marks, and 4 marks, right? But of course, when you are solving, you use the frequencies, right? So that'll be 9 plus 14 plus 13. Please teach Sandra for me. I said at most 4 marks. Chirimu or more dialect more better. Prince, what's your answer? Prince. No, who are now? Is he in the class? Do you understand? What's your answer?
Yes.
What can you say? Then I walk Hebrew or Tree or English. Then I walk Prince. What's your answer? And won't you ask you on class on Casa? Oh, I don't know why you guys don't get it. What part don't you understand? And let me explain all over again. For video, no, I will upload the video, but I mean, someone question and normal. Into the aunt as a moon can I mention our hands and a macro. A moon share, and that's all. You don't watch, you don't even like the videos. I'll delete it. Prefect, Busamu, then what exactly is their problem now? You're sorting it out.
Do you understand? Yeah, I understand.
Oh, because I'm going to catch you on what you ask you, or when your papa. Find a way to ask them where exactly they don't get it. Call Prince class one to be asset.
I'm sorry, it's teaching. So which part do you understand? You don't understand? At most. Which part don't you understand?
When he said Anthony is explaining it to me.
Ah, okay, okay. But guys, I'm writing this. Normally, your class at most, imagine this, not more than. Like, that's another way to say at most. So, find a probability that the student obtained not more than 4 marks on. Near can 4 marks, or the 7 marks. Find a probability that the student obtained not more than 7 marks. Now my cultural say, my cultural say, exam no more actual. Exam no more you know. The marks they had is 2 marks, 3 marks, 4, 5, 6, 7, 8, 9. Now me say find the probability say akola ye chusu nkola be free class. Ye chusu akola. They said a pupil. Hey, see, listen. Probability is important to read the question. They said a pupil. Sometimes you bet me a cultural say 2 pupil are taken from the class. Meaning say, and what's all you one-sided. Also, you have to look at it from a perspective of pulling out 2 persons. Yeah. And see, I don't know, open see you so like intercession and union stuff kind of thing, no? I with me. We'll come to that. You say a pupil is taken from the class. Now find a probability to say the person obtain at most at most or when at most 7 marks. Me say at most here then. So not more, the people obtain not more than 7 marks. Into bet me anya marks ni bia marks bia wo biase bia, but not more than 7 marks. What does it mean? Uko choose 8 more than 7. Uko choose 9 more than 7. Me say me pay anything more than 7 marks. Oh guys, I need some mobile money, okay? I don't want anything more than 100 cedis. What does it mean so mommy 100 I mean Gianna?
But
Does it mean so mommy 100 cedis I mean G? I'm like I'm broke. I need some money, guys. And say how much do you need? Oh, anything but no more than 100 cedis. So it doesn't mean umami 100 I mean G. Meaning so bet my mom's 100 cedis so bet me I but no more than 100 cities. So 101 maybe I mean and I mean maybe some I will not take it. Do you understand? But 100 cities. So any number per the table, any number be but not more than 100. So if I say the student obtain at most 7 marks, meaning any number but not more than 7. So we are looking at 2 marks, 3 marks, 4, 5, 6, 7. But don't use the marks so use pupil no you see ye nipa ya cause ye marks. A pupil is taken at random to find the probability that nipa na you find obtain not more than 7 marks. Into one say not more than 7 marks, you sure more munya 2 marks, 3 marks all the way to 7 no. No akofa sound crofon. Into more munya 2 marks, no me 9. So 9 plus 14, 14 for 3 marks plus 13 all the way to plus what? 8. What you saying? They say one tiasia, this is a bold deliverance. What you saying? Are they off the meeting? Oh, they are here. Oh, they went off. Damn. Okay, so for that same question, let's add a lot more preamble. Oops. The same preamble. Let's add a lot more questions. Sorry. So, IV or VI, whatever it is. Obtained At most 3 marks. Vin, well, your own numbering. Obtained at most 8 marks. Next one. Obtained at most. Mr. Obin calling me. Hey, Mr. Obin. Onim, me meeting says ya maybe no. Mefro says ya and come on. Mefro. Bye. Yeah. What is it? My what did I see? Obtain what?
At most 8 marks.
Okay. Let's add one more. Obtain at most 5 marks. Here we. All right. Any questions so far? This brings us to the end of today's lessons. When next I meet you, we would be continuing from where we left from. Any questions?
No, sir.
No, sir.